Okay then, so we're going to start the final session for today. It's not more than I can say. Patricia is now working for Laser Fence. How long ago did you do your Viva?
3 months maybe, it was in December.
Okay, so she's not long been doctored, and as you'll see, her work is all to do with the problem of metals in the environment, and yeah, I'm looking forward to hearing about it.
Thank you. Yeah. I'm lucky to have an audience that is gonna listen about my PhD research, I think. Right. So how Martin said, thank you for your introduction. I work in metal impact, and particularly what happened to the ecosystem when we have mining impacted metals around. So these are some news from different journals, and we have problems with the amount of metals that are in the system, which are released during a flood event, and the issue that we have to address, and this pointed out also from the government, and the Water Framework Directive from the EU is starting to pull together a lot of energy and trying to reach what is some standard and some protocol where we understand where the metals coming from and how can we quantify them, understand where what they are impacting and what we can do next. So we have our nice ecosystem and all the mining process that's been going on for centuries. And what we have now after the mine being closed are a lot of farms and agricultural fields and some buildings that sometimes are heritage buildings. So we can't even work on them in terms of if remediation is needed. We have to be aware that some places are need to be preserved as well as monitored for the metal release. As in the mining, as said, they were around for centuries, and this means that all the buildings around for centuries means they're historical buildings. So the problems that have been accumulating with time are the amount of lead and zinc and other nasty metals that are in the soil and in the water. And they are worldwide spread and basically are mostly focused in catchments, just because the mining have been settled mostly up to the mountain, because the mining process was to extract the ore from the ground and decrease the size of the rocks to extract the metals, and this means that they need the energy, and the energy they used, especially in the past, was gravity, and the gravity was easily found up to the mountain, and because of the grade of the river going down to the valley, but also because the ores found in some orogenic. For the geologic point of view, they are found in a mountain because of the orogenic background which have formed them. So the catchments are carrying a lot of metals, and catchments means a lot of energy. So we have chemical processes going on which distribute metals for all the catchment, but also we have physical process which move the metals from upstream of a mountain down to the valley next to the other river and go to the sea and to the sea. So they travel a lot from the mountain down to the sea, and the metals are subject to a lot of transformation in the meantime. So the metal itself doesn't change, but it can go through an organism. It can go so from the plant that is been then eaten by the cow, and then the cow or the milk has been used as product in the food, and so the metals doesn't change. It may affect our body in the meantime, and he always create a kind of waste or toxic effect on the ecosystem. So it is important that we understand where the sources are. How can we put a number on it so we can monitoring the effect of what we do in terms of remediation schemes, and trying to understand who is going to be impacted by these metals going around. So my field site was in Wales, so I used this slide for a conference in South Africa, so I couldn't be really specific on the name of the mine, but it was Wemyss mine nearby Aberystwyth, and particularly the area of Wales was really rich, and is really rich in lead and zinc. Now there are not any mines still active, but we have a lot of waste that are distributed through the catchment on the top of the mountain. And if we think about Wales, we also think about greenlands and grass and a lot of animals. So the two images are together in the same ecosystem. So from the Environmental Agency, we have an idea of where the risks are located. And in particular, I've been looking to Wemyss mine and Gregok mine, which are the two mines highlighted in yellow. And the name of the river is Comedian River, which I called it CMD for a while because Welsh sometimes complicated. And the river goes down to Afton Eastwith, down to Aberystwyth, and then to the Irish Sea. And the Irish Sea has been monitored for a while together with the Atlantic Ocean Scheme to understand the amount of metals going down there, and have been calculated. I don't recall the numbers now, but a lot of metals that go down to the sea are from the mining. So a lot of small mining have an impact when are all together calculated then down to the Aber of the river, so the mouth of the river. So Aber is the Welsh name for the mouth of the river. This is why we have Aberystwyth, for example. Just interesting fact. So in this area we have high concentration of zinc and lead, and the concentration, just a number from a downstream point, for the quality standards under 25 microgram per liter for zinc and 7 for lead, as you can see. And red one are the ones that have been reported by the Environmental Agency, which are incredibly higher compared to what is supposed to be as good quality. So we have all the Welsh government and, of course, all the people that live there being being scared about the amount of the mining which are polluted the system. So just to give you some images to put in your mind about the area, we have Wemyss mine, which looks quite grey, and because of the amount of metals and the big slope, vegetation rarely grow on top of it. And then we have Gregok mine, which looks a bit different, more greeny, and usually is quite active in terms of a lot of sheep around and farmers as well, which take care of all the rivers and the slope itself. And then this is an area which, moving downstream, is really green, and a lot of animals are around, and there are ducks nearby, and I'm going to refer to this point sometimes as Duck Point, because of ducks were dying because of lead pollution, and it's stuck in my mind, and I'm usually just referring to Duck Point, also because this research involving a lot of field work. Sometimes when you're in the field, you need to have some snappy names, and I just call it Duck Point. So if you hear this is just referring to Duck Point. Then downstream we have the floodplain, where because of the variation in the gravity, all the water slowed down. We have the precipitation and deposition of sediments, which are coming from the upstream mining, and we have a lot of farming and animals going around, usually in here. And then this is the last point have been measured. So from the upstream point, which is Wemyss mine, to downstream, there are almost 6 kilometers, which is a reasonable measure to call it a river catchment. So my question was, where are the sources, and how can we measure the impact of these sources in terms of soil and water quality? So I did soil and water investigation using an XRF gun, which is just similar to gun. So you use an XRF to basically give me the amount of element that we have there in terms of concentration of zinc and lead, other metals, and then a microprobe and EDS, which give me information about minerals, so the mineralogy that we have in the soil. So next, the other element that I'm going to look at is the water, but I'm going to talk about this later. So using the XRF gun, soil has been taken from the riverside, been brought back to the lab, and we have measured the amount of lead in the area. We can see that the highest point with lead are in the upstream point, which is normally is where the mining are. And then downstream where the ducks were dying, we have 0.42% of weight percent of lead, which is a big average. It means that the lead is starting to mix with other soil that wasn't contaminated, and when you get a measure, it may be really random. So it may be that you're picking a piece of soil which contain lead, or maybe you're taking another piece of soil which not contain metals, and then you have a huge range of elements. So you need to be aware that you can't really average them. You need to take a range of metal concentrations. And then downstream we still have, so in the floodplain, a variation of concentration, we can be 0.2, 1.1 weight percent of lead, which are really high concentration of lead. And this is why the ducks were affected in Ducks Point. Then from the mineralogical point of view, so using the microprobe, I've been doing slide in the microscope and been analyzed them with EDF. So an instrument giving me maps of the 1 micrometer big images with high resolution metal content. So I was able to recognize a different kind of mineralogy which was there. And then we can see the galena, which is the element, the mineral that they use as primary sources. So it's lead sulfide is gonna be more present in the upstream because it's the one that come from the rocks itself that they gonna process, and then how we move downstream. So from the more brown part to more the yellow part, we have more iron oxide and phyllosilicate, which are some minerals. They have the they have the lead just sitting on the surface, absorbed, and not really into forming the minerals itself, but they are just absorbing the metal. And it means that they can release the metals easier compared to a galena or anglesite minerals which have the lead inside the mineral. So the question is how these metals, so the metals are there, are in the soil, but how do they move in the environment? Does the stream flow, the draining affect it? And this is a really important question, especially in Wales and UK, where the weather conditions change a lot, and then the concentration in the water can change a lot as well. So if you have a metal concentration, a lead concentration, zinc concentration in a day which is sunny, it may be different in a concentration that you have another day, which maybe is raining, or so you have more water. So how you can understand what is the pollution at the end that you have in the area. So you need to understand how these metals can be released across all the stream flow conditions. So here comes the stream flow effect on lead flux or zinc flux. I've been using both of them, and I've been using tracer injection to estimate the load, so to estimate the amount. At this point, I'm not talking about concentration anymore, or I'm adding to the concentration quantification also the load, because I'm going to multiply the amount of concentration for the amount of water. So I have the amount of metals that move through a second, and not just the amount of metals that is in a liter of water. So I can compare what is going to happen with the dilution. So if I have more water or less water, is the amount of lead increasing or decreasing? Is it the dilution actually impacting the amount of lead, or is actually I have less concentration but bigger volumes, I'm going to have more lead or more zinc. And for doing so, I need to have a really precise information of the stream flow. So concentrating in the upstream part, I'm going to just briefly say what is going on as a tracer injections, which may be a bit confusing if I squeeze it, but we'll see what I can get. So in the upstream point, I'm going to release a tracer into the stream flow, and how I release the tracer is going to move downstream, and how it moves is going to dilute through the water, and the dilution is going to just plateau at some point, and because it is going to infiltrate in all the area of the river, and once it happens, if it doesn't rain, you don't have any change in volume, and you have a saturation, and you have a plateau. So this tracer, in all the point of the river, because of its dilution, it can give you the quantity of the water, the volume, the discharge. So for each point where you have the tracer concentration, what you do is you move downstream from, you walk from the river, and you take a lot of samples when you have the tracer injected. And so you're going to have for each sample the concentration, you're going to multiply the concentration for the volume, and you're going to get the load. So this is what you do to get a load to measure of metals. And when you pick samples, you're really detailed, careful to take a lot of samples through the way, so you can have a really precise information, detailed information on what is coming from the side of the mining, because you can, for each spot, have the concentration and the lead. So if we move from upstream, which is 0, to downstream, 2,500, we can have for each point, which are the point where I was taking the samples, we're going to have the concentration, which are here, and the load. As you can see, there is a big difference between the concentration and the load. So sometimes you have an increase of concentration, which is the same in the load. It means that we have a lot of water coming, which have really high concentration, but also a lot of we have a lot high concentrated water coming, and there's a lot coming with it. So we have a big increase in the load as well. Other times happen that we don't have any increase in the concentration, but you have increase in the load. It means that you have more water coming, which may have a steady or lower concentration, but you have a lot of it. So in terms of volume, they're carrying more contaminants. So doing that and being all the points really precisely taken in all the sources that I thought were important for the site, I can individuate where the concentration is increasing. This is Gregok mine, the one that we saw where the farm was active. And we have Frongokadit, which is an adit coming just below Wemis mine, which is the gray area where all the mines were. So for each point, what I can do then is from the load, I'm gonna check for each segment of the load. So from here, for each segment, I can measure the increase of the load compared to total amount. So I need each segment of the river, how much is going to impact on my total, the total amount of metals. So it gave me, basically what it gave me is a plot of what is coming through the side of the river. So for Gecko mine, we have an incredible huge amount of 30% of metals coming from the side, which we didn't expect it because we didn't see any gray spoil or anything which we can, anything that was giving some idea of contamination coming on because of the metals which are, you can't really see them, can you? And another points, which are Frongokadit and Wemis mine, which is still really impactful on the area. And the other point is, okay, we know where the sources are and how they, how much they impact in the total of the sources, on the total of the metals, but how does it change during stream flow conditions. So for Gregok mine, again, which is here, we have variation in concentration during different situations. So if during dry weather, we have concentration which are 3.43, and when it can change between 1.43, 1.95, or be 2.30 when it's storming, when it's raining a lot. If we check then the load, so the amount of volume and the amount of concentration multiplied for the volume, we can see that the amount of zinc when it's storming moving through the system is incredibly high compared to the amount of zinc that move when it's dry conditions. So we need to take home from here is, okay, we can identify sources, and we need to be aware the sources may change during streamflow conditions. And the other question is, okay, this happened in the upstream part. How does it affect the total of the catchment? So using some slag or some method to measure the stream flow, which are really quick, just 20 minutes operation where you can get the stream flow in all the point. We have, just to repeat, the upstream, I needed to flip it, is the Weymouth mine. When you move downstream, so we have the 6 kilometer going to the floodplain, and we have our point of sources, which are Weymouth mine and Gregok mine, and from Gokadit, which are just coming next Weymouth mine. And how they increase is in load is really obvious that it's still affected all the river. So if we have Weymouth mine coming here and Gregok mine, you're still adding load to the metals. So when we move downstream the mining area, we still have a lot of water coming, which can give you a bit of dilution processes, but also deposition processes. So in this case, considering that we're not considering volume. So also if we have more water, we have some precipitation of metals going on. And then where the ducks are dying, just in this area, we have lower concentration of metals in the water. It means that they are accumulating in the soil. And then just after it, especially during high flow, you have a release of metals. So where the ducts were affected, we actually have a process where the water were slowing down because of a geological trap. And because of it, the soil was slowing down, and it was depositing the soil and the lead, which usually is a heavy element, and is subject to gravity more than other metals. And when the energy of the river is higher, it's going to be mobilized again. So this is why you have ranges of concentration. So this graph showing average and max and minimum in different stream flow conditions. So it's the result of different days, and just to give you a spectra of what kind of load you can have in around 3 years' time. And then downstream again, so after the ducts point, you can find still deposition of metals, and then again the floodplain where the farms are, you still have a lot of metals coming down. It means that these two processes are really related to the geomorphology going in the valley. And the high flow can really generate, they can really spread and disperse the metals around the floodplain, which is what has been observed during a massive flooding event, also in 2012 in Wales, where there are a lot of cattle that were animals that were suffering because of the lead and zinc concentration, which have been spread in an epic flooding event. So I haven't been sampling where there was really flooding, a massive flood event going on. So this is a situation where extreme events are not even counted. So if we have extreme event, this concentration of this load can really increase even more, and then be more impactful on what is going around the river. So along these 6 kilometers, so it's just a small piece of land in a big area, right? But we have both economically impact on it because of the cattle downstream may be affected, or the fish, especially in the abrasive part, may be affected from the metals, and who else can be impacted? So being a beautiful area in the middle of Wales, we have a lot of recreational sites. So we have just along the river, especially this is Ducks Point, we have places where we have some pool sites where people can just go there for a weekend and enjoy the sun and have a bath in there, and without being even aware that down their feet they have arsenic, lead, and other nasty stuff which are really toxic for the humans and the ecosystem in general. So she's Natasha. She helped me with the loads of field work that I've been doing in Wales, and she's wearing a raincoat. It's not raining now in the moment of the pictures. It means that in Wales can rain any moment. You always need to be prepared. And downstream in the floodplain, we have a lot of farming going on. Still a kind of rural stage of farming. We don't have intensive farming. This is the houses of of the farms. They are just down on the side of the rivers, and they have the cattle and the cows and the sheep just on the side of it, which cross the path of the river really often, and other houses are just in the middle of the valley. With this is the house of the lady that was owning the ducks, and you can't really understand how much is the impact also because of all the growing vegetation, which helps with the vegetation to grow. Also, if the concentration of metals are high, which means that also if the concentration are high, you have vegetation. Also, if the concentration of metals is high, you have vegetation covering it, and it's difficult to detect the pollutions coming through. And so what you do is just you don't see the danger, and you just proceed without even being scared of the situation. And so we used to go there during daylight. So how you can see from the picture, the mine spoiler is actually really active because there are a lot of prints going on. So we have a lot of birds that just stay on the top, and rabbits that they create holes around, and they have they created the Onnis as their habitat as well. So the wildlife, not just the ducks from the lady downstairs or the cattle, or cattle is not the right word, is it? Is it? It's not just the boiling machine. Cattle. And so we have a lot of animals also in the wildlife which are impacted by these areas and these metals. So I try to squeeze all the metals that have been used and to result in discussion, hopefully something I could communicate something in terms of we have metals which are released and we don't really see them apart from when they are really reddish and with colors or where vegetation or cover on top, and a lot of life is going on there as well. So I would like to conclude with a question for you. Can we use laser technology to protect animals from these harmful playgrounds? Then, for example, during flooding events, you may have some, so the water moves with high turbidity and it goes on top of valleys and in fact it goes into the farms. Maybe if we can protect the cattle to go in the polluted area, which is sometimes impossible just to build a fence or build a fence along over the river, maybe with a laser it's just easier to redirect them. Or maybe on a mining spill or tips which are really dangerous and they have nasty stuff because they are the source of all the metals which spread downstream. We saw that we have rabbits and birds and deers that they just go down there. Maybe we can put a laser to stop them to create an habitat in them. It may be handy. and being these places in the middle of nothing is also easier to control. I mean, they can give you with low assistance, they can give a good protection to animals, maybe.
Good question.
Off you go.
Thank you, Patricia.
Thank you.
Any questions, Patricia?
Isn't it under EU water framework rules? Isn't it a legal case that shouldn't happen?
Yeah, so the directive says, okay guys, we need to try to reach a water quality standards by 2015 was the first one. But it is such a complicated issues because sources are all over. We can't see them because metals are just, I mean, they are elements going through places which we don't see them. So we have to use a lot of instrument or tools to detect soil contamination and water contaminations. And it's just a slow process, especially because sometimes from the Water Farm Directive, they set some goals sometimes which are really hard to reach because they don't consider that these areas mineralized. So in theory, you can't even reach the standard quality because before the mining, the concentration were higher, okay, because of the amount of metals that were there. This is why they did the mining there, the mines there. So this is one of the problem. This was one of the problem. And the other problem is that understanding where the sources are coming from is really difficult. So the method I've been using are from the USGS, from America, and they haven't been using here in UK, just because when I said the tracer need to be dissolved in all the water from 6 or 2 kilometers, it means that you need to have a window of time with no rain of 2 days, which is really difficult to reach in the UK. So this method has been really used outside where you have seasonal patterns in weather, can be used and can give more response. In UK, we have struggling to understand where the sources are. And if you don't understand where the sources are, you can't address them. Okay, so not for showing off, but this was the first case in UK where diffuse sources, so sources that were not, they're not easy because they're not points, so you couldn't put a number on it because of the amount of question mark you have. Different type of soil, you have different vegetation. So it was the first time that this method been used and the first time that diffuse sources been counted in the UK. So there is still a lot of things to do, and yeah, it's not an easy issue because also still need to repeat a point. It rains a lot. It means the vegetation is covering a lot of things we don't see. And if you don't see them, they are even more difficult to understand where it comes from, it's difficult to address. So we're working on it. But yeah, it's not that there is a policy and then things are suddenly sorted. It takes a lot of time. People to be trained for using different methods, and challenging. Yeah. And also when you understand where the source is coming from and you can put a number on it, some places are part of ecological status, they're protected. You can't act on them with remediation strategy unless all the stakeholders are contacted. So it is a working process. I mean, we're working on it. Did you answer? We have a question from.
Quick question: is there anybody actually looking at lead in the wildlife in these areas?
So from what I'm aware, the duck body has been transferred to Nottingham University, and I'm not 100% sure, but one of the university have the duck of the body and that they're working on it. Okay. The body of the duck, not the duck of the body. Yeah. So there's something going on.
Okay, but it's not like a systematic.
No.
Sort of survey.
At least I'm aware of Ilaria. Yeah. Yeah. Mm. Mm. Not in my site, yeah. Yeah, it will be interesting to see how much the wildlife is uptaking from the metals, because the amount of erosion that the mine tips have from rabbits is incredible. So you have, I mean, the wildlife, he creates the habitats there, right? So it's full of tunnels. The mine tips are full of tunnels, which it destabilizes them, right? So they're really active. So I'm sure they have some lead in their blood. But yeah, but it's certainly a path to follow. There are no fish in the river at all. It's fishless. Yeah.
Just going on what you just said there, Patrizia, is that could you quite easily tell a river is polluted a lot by working out how many fish that are present? Is that
Again, sorry.
The fish are a very good indicator on
yeah,
pollution.
Absolutely, yes, yeah. There are some. So the river's been investigated from. I don't remember the name of the organization. Is a Welsh Fish River something. I don't remember it. I'm just putting a name together. But yeah, they studied it and they just declared it fishless because of the pollution. Yeah. Mm-mm. Yes.
Am I right in thinking that that this could potentially be an issue in lots of mining areas?
Yeah. This is an example of what happens. I've been with Philadelphia here. We've been working a bit in different mining situations, also in Lead Hill in Scotland, and we've been working Paris Mountain, but all the areas that the fact is the mining have been built on top of mountains because of energy wise and because of the geological formation of the mining themselves. The ores are there, so the veins basically were just growing on top of the main vein carrying all the metals. Were just going on top of the going through the orogenic compression of the land, which is all the geological background. But yeah, this is why the mining are there.
And once the mines closed, they just left.
So mining process been going on for, I don't know, Bronze Age. I mean, we need metal, so we can't just close our eyes. But the awareness of pollution arose around the 1800s, where they're starting to have some reports about. They started reporting the vegetation that was going off. Basically, it was turning yellow and then dying when concentration of metals. I don't even know what they were talking. About concentration of metals, but when, especially after flooding, because what they did for a long time was they were extracting the ore and they were just living on the side of the river and waiting for the storm to come. So the storm was coming and then distributing everything downstream. And I forgot the question.
Oh no, you answered it.
Okay.
Yeah, just that the mines are left when they close.
And then there was not aware of it, and then they started to report that the vegetation was dying and animals were not there anymore, or they were just that something was going on which is not good. Then it took at least 100 years to put it on paper, and then we are still adjusting to it.
I did a little peg once on bioavailability of lead,
Mm-hmm.
shooting corpses.
Yeah.
And the happy side is that your soil pH has to be pretty low
Mm-hmm.
for the stuff to move, to be taken
Yeah.
by plants.
Yeah.
So I guess you are dealing with geology of that nature.
So in some areas you have, especially when the geomorphology goes on, you have a series of clay and sand alteration layering, which can really work on redox situation, and redox can influence the dissolution of some minerals. Minerals can generate, or also the organism can decrease the pH. And once the pH decrease, you have the release of the metals. So you can have it in some situation, and this is why during the stream flow you have some patterns which can happen. And yeah, but you're right, pH, there are a lot of variability to take account for lead bioavailability. Yeah, and unfortunately all the variability change with time as well. So yeah, pH may be stable one day and then you go after a flooding event which was flooded for a month or a week, and then you decrease the pH and then you have lead in the water. Yeah.
I know in some countries they use plants to soak the stuff up
Mhm.
and then they incinerate it and catch what's left.
Yeah.
Which is a smaller volume. I think we do that in Scandinavia, don't they?
Yeah.
I studied as well during my bachelor assessment where we used a plant that was growing just in Sardinia to evaluate if it could be used for phytoremediation.
Yeah, phytoremediation. Phytoremediation.
Phytoremediation. But at the end of the study, it was evaluated that could have been used just for stabilization. Like you could find the metals not in the leaves, but just inside
Yeah.
in the roots. So it was considered. There is some index to evaluate molecular property, but depending on the index, you can evaluate if a plant can be used for stabilization or for proper remediation.
Yeah. They tend to use local plants.
That was
They're trying to use local plants also, because when you do remediation, you need to take in account all the ecological site protection, and you can't. Sometimes people don't want you to introduce anything that is not part of the ecosystem. So yeah, there are some plants that are more suitable for the purpose, but not always you can use them.
Yeah.
And sometimes what they need is using combination of plants and bacteria to help them to develop an habitat. So you put a plant and then you inoculate bacteria that are from the area, and so the plant is more able to adapt to the situation. But you can have we've been to a barista conference, and there were people talking about how the plants were also adapting to the variation in still raining conditions, when it was raining, when it wasn't raining, because sometimes plants need also to be fertilized, so they need more water. So you need to understand what are the optimal conditions for them to grow and to stabilize it. From there as well. Yeah. But yeah, there are studies about it too. Applications are still going on, more lab-wise. Yeah, but enough. Thank you.
Okay, thank you very much. I think we got our money's worth.
Thank you.
Okay.